Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter Summation of Trigonometrical Series, lecture number 10, in which I will solve some more problems by method of difference. Now we solve a problem. Problem is find the sum to n terms of the series cot inverse under bracket 2a inverse plus a plus cot inverse under bracket 2a inverse plus 3a plus cot inverse under bracket 2a inverse plus 6a plus cot inverse under bracket 2a inverse plus 10a plus dot. Now we solve this. Here we see that here 1a, here 3a, here 6a, here 10a. Let Tn be the nth term of 1, 3, 6, 10, dot. And Sn be the sum to n terms. Sn equal to 1 plus 3 plus 6 plus 10 plus dot plus Tn. Again we write Sn equal to 1 plus 3 plus 6 plus 10 plus dot plus Tn. Now we subtract. Here we write minus. So left side 0 equal to 1 plus here 2 plus here 3 here 4 plus dot to n terms minus Tn implies that Tn equal to 1 plus 2 plus 3 plus 4 plus dot to n terms implies that Tn equal to, this is n into n plus 1 by 2. This is number 1. Let capital Tn be the nth term of the given series. Therefore, capital Tn equal to cot inverse 2a inverse plus n into n plus 1 by 2a. This is equal to cot inverse 2 by a plus n into n plus 1 by 2a, and this equal to cot inverse 4 plus n into n plus 1 a square by 2a equal to cot inverse. We take common 4, here 1 plus n by 2 a multiply n plus 1 by 2a. Here n into n plus 1, here 4 and a square. Here we take common 4. So remains a by 2. We may write this cot inverse 4 cancel 1 plus n by 2 a multiply n plus 1 by 2 a here n plus 1 by 2 a minus n a by 2 here n by 2a plus here n by 2a minus cancel only remains a by 2. So here a by 2 and this 4 cancel. This equal to cot inverse n a by 2 minus cot inverse n plus 1 a by 2. Let this is number 2. Putting n equal to 1, 2, 3 n, we get capital T1 equal to, here in place of n we write 1 cot inverse a by 2 minus cot inverse a. Here n equal to 1 plus 1 2 by 2 1 T2 equal to cot inverse n equal to 2 by 2 1 cot inverse a minus cot inverse, here n equal to 2 plus 1 3 by 2 3 by 2 a T3 equal to, here cot inverse 3 by 2a cot inverse 3 by 2a minus cot inverse, here n equal to 3 plus 1 4 by 2 2a and dot Tn equal to cot inverse Na by 2 minus cot inverse n plus 1 a by 2. Adding these we get T1 plus T2 plus T3 plus dot plus Tn equal to, here we see cot inverse A negative, cot inverse A positive, this and this cancel, cot inverse 3 by 2 A negative, cot inverse 3 by 2 positive, this cancel. So this diagonal will be cancelled, only remains cot inverse A by 2 minus cot inverse n plus 1 a by 2. This is the required answer. Now we solve the next problem. Next problem is find sum to n terms cot inverse under bracket 1 square plus 3 by 4 plus cot inverse under bracket 2 square plus 3 by 4 plus cot inverse under bracket 3 square plus 3 by 4 plus dot. Reduce the sum to infinity. Now we solve this solution. Let Tn equal to nth term. Therefore Tn equal to cot inverse. Here 1 square, here 2 square, here 3 square, then nth term, in nth term n square plus 3 by 4. This equal to cot inverse 1 minus 1 by 4 is 3 by 4 plus n square. This is equal to cot inverse 1 plus n square minus half square. And this equal to cot inverse 1 plus, here a square minus b square, n plus half, n minus half. This equal to cot inverse 1 plus n plus half, n minus half by 1. We may write this cot inverse 1 plus n plus half, n minus half by n plus half minus n minus half. Here n is positive, here n negative, cancel. Half minus minus plus half, half plus half 1, implies that Tn equal to cot inverse n minus half minus cot inverse n plus half. This is number 1. Putting n equal to 1, 2, 3, dot 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 n, we get T1 equal to cot inverse n equal to 1, 1 minus half, half minus cot inverse 1 plus half, 3 by 2. T2 equal to cot inverse n equal to 2, 2 minus half, 3 by 2 minus cot inverse 2 plus half, 5 by 2. T3 equal to cot inverse, here 3 minus half is 5 by 2 minus cot inverse 3 plus half, 7 by 2, dot 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 dot, and Tn equal to cot inverse n minus half minus cot inverse n plus half. Adding these, we get T1 plus T2 plus T3 plus dot 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 plus Tn equal to, here we see that cot inverse 3 by 2 negative, cot inverse 3 by 2 positive, cancel. Here cot inverse 5 by 2 negative, cot inverse 5 by 2 positive, cancel. And similarly this diagonal cancel, only remains cot inverse half minus cot inverse n plus half, and this is the required answer. When n tends to infinity, then cot inverse n plus half equal to 0. Therefore, sum to infinity equal to only remains cot inverse half. Now we solve the next problem. Next problem is find sum to n terms cot inverse 2 plus 1 plus cot inverse 2 square plus half plus cot inverse 2 cube plus 1 by 2 square plus cot inverse 2 to the power 4 plus 1 by 2 cube plus dot 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 dot. Here we see that in the first term 2 to the power 1, in the second term 2 square, in the third term 2 cube, in the fourth term 2 to the power 4. Let Tn equal to nth term. Therefore, Tn equal to cot inverse in nth term 2 to the power n plus 1 by 2 to the power 1 less means n minus 1. This equal to cot inverse here 2 to the power n minus 1, 2 to the power 2n minus 1 plus 1. We may write this cot inverse 1 plus 2 to the power n multiply 2 to the power n minus 1. This is n plus n, 2n minus 1 by, we may write this 2n minus 2n minus 1 because 2 to the power n minus 2 to the power n minus 1 equal to, we take common 2 to the power n minus 1, here remains 2 minus 1, this equal to 2 to the power n minus 1 multiply 1 equal to 2 to the power n minus 1. Therefore, in place of 2 to the power n minus 1, we write 2 to the power n minus 2 to the power n minus 1 here, and this will be equal to cot inverse 2 to the power n minus 1 minus cot inverse 2 to the power n. Let this is number 1. Putting n equal to 1, 2 dot 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 n, we get T1 equal to cot inverse n equal to 1. So here 1 minus 1, 0, 2 to the power 0, 1, cot inverse 1 minus cot inverse 2 to the power 1, 2, T2 equal to cot inverse, here in place of n2, 2 minus 1 is 1, cot inverse 2 minus cot inverse n equal to 2, 2 square, T3 equal to cot inverse n equal to 3, 3 minus 1, 2, 2 square minus cot inverse 2 cube and dot 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 dot. Tn equal to cot inverse 2 to the power n minus 1 minus cot inverse 2 to the power n. Adding these, we get T1 plus T2 plus T3 plus plus Tn equal to, here cot inverse 2 negative sign, cot inverse 2 positive sign, cancel, cot inverse 2 square negative sign, cot inverse 2 square positive sign, cancel. So this diagonal cancel, only remains cot inverse 1 minus cot inverse 2 to the power n. This is the required answer. We have to solve the next problem. Next problem is find the sum to n terms. If this term is deleted here and we take the first term cot inverse 2 square plus half, the second term cot inverse 2 cube plus 1 by 2 square, third term is this, and so on. Let Tn equal to nth term, then Tn equal to cot inverse, here in the first term 2 to the power 1 plus 1, here n plus 1, and then it will be 2 to the power n, means 2 to the power 1 half. The nth term will be this, and we may write this is 2n plus 1, here 2n, and we may write this 2n plus 1, here 2 to the power n, here 2 to the power n plus 1, here 2 to the power n. Since 2 to the power n plus 1 minus 2 to the power n equal to 2 to the power n common 2 minus 1, here 2 to the power n. So in place of 2 to the power n, we may write 2 to the power n plus 1 minus 2 to the power n. So the formula will be 2 to the power n cot inverse 2 to the power n minus cot inverse 2 to the power n plus 1. Putting n equal to 1, 2, n, we get T1 equal to cot inverse 2 to the power 1 means 2 minus cot inverse 2 square, T2 equal to cot inverse 2 square minus cot inverse 2 cube, T3 equal to cot inverse 2 cube minus cot inverse 2 to the power 4 and nth term will be Tn equal to cot inverse 2 to the power n minus cot inverse 2 to the power n plus 1. Adding these, we get T1 plus T2 plus T3 plus Tn equal to, here cot inverse 2 square negative, cot inverse 2 square positive. This cancel, and this diagonal cancel. Remains cot inverse 2 minus cot inverse 2 to the power n plus 1. This is the required answer. Now we solve the next problem. Next problem is find sum to n terms cot inverse 2 multiply 1 square plus cot inverse 2 multiply 2 square plus cot inverse 2 multiply 3 square plus Now we solve this. Let Tn equal to nth term. Therefore Tn equal to, here in the first term 2 multiply 1 square, here 1 square, here 2 square, here 3 square. So in nth term we will get here n square. We may write this tan inverse 1 by 2n square, and we write this tan inverse here 2 by 4n square. We write this tan inverse 2 by here 1 plus 4n square minus 1. We may write this tan inverse 2 by 1 plus here 2n square minus 1 square. This is equal to tan inverse here 1 plus 2n plus 1 2n minus 1. So here we may write 2n plus 1 minus 2n minus 1. Here 2n positive, here 2n negative. Cancel 1 minus minus 1 plus. So 1 plus 1, 2. And we may write this as Tn equal to tan inverse 2n plus 1 minus tan inverse 2n minus 1. This is number 1. Putting n equal to 1, 2, dot, 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 n, and then we may easily add n terms. Now we solve the next problem. Next problem is find sum to n terms cot inverse 1 plus 1 plus 1 square plus cot inverse 1 plus 2 square plus cot inverse 1 plus 3 square plus dot 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 dot. Here we see that here in the first term 1, in the second term 2, in the third term 3, and here 2, then here 2 square, here 3, then 3 square. Let Tn equal to n terms. Therefore Tn equal to cot inverse 1 plus here n plus n square. We may write this cot inverse 1 plus, we take common n, here remains 1 plus n, means n plus 1. We may write this cot inverse 1 plus n into n plus 1. Here we may write n plus 1 minus n. Here n positive, n negative, cancel, remains only 1. So we may write this cot inverse n minus cot inverse n plus 1. This is number 1. Putting n equal to 1, 2, dot, 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 n, and then adding, we get sum to n terms. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.